There are moments in the quiet of night when we look up at the sky, and something stirs deep within, a primal sense that we are small, yet part of something vast and unfathomable. It's in that quiet tension between curiosity and insignificance that the greatest stories of the cosmos begin. Imagine a theater not built by hands, but by gravity and time, where the curtains are made of dark matter and the actors are stars, dying, being born, and drifting in silence. Now imagine that this grand stage is just a small corner of a far larger mystery, one whose secrets could rewrite everything we think we know, not just about space, but about ourselves. Welcome to the unknown. Welcome to the mysteries of space. But before we continue, subscribe to the channel and like the video. Despite the centuries of skygazing, astrophysics, and space travel, the universe refuses to give up its most beguiling secrets. Scientists speak of dark matter and dark energy, terms that sound like answers but are placeholders for what we don't understand. We know there are billions of galaxies in the observable universe, but we can't see most of what's actually in them. Even our home, the Milky Way Galaxy, is a riddle wrapped in a spiral of stars, cloaked by cosmic dust, and bound by the invisible. Our Milky Way is not just a backdrop, it is a mystery in its own right. We often picture it as a flat disk, spiraling like a celestial whirlpool, a glittering sea of over 200 billion stars, stretching 100,000 light-years across. Yet, what we know about it is disturbingly shallow. We are like insects crawling across a single page of an ancient book, trying to decipher the entire epic without ever turning the page. The galaxy's heart is a dark and violent place, home to Sagittarius A, a supermassive black hole weighing over 4 million times the mass of our Sun. We cannot see it directly, but its gravity warps the orbits of stars around it, as if choreographing a cosmic ballet for an unseen director. One of the great mysteries lies in the structure of the Milky Way itself. Astronomers long believed it had 4 major spiral arms, but newer data from infrared surveys and the Gaia Space Observatory suggest that our galaxy's architecture is far messier, asymmetrical, and dynamic. Some arms seem to fragment. Some may not even be arms at all, but rather flocculent streams of stars drifting like waves in a galactic ocean. We don't know how the spiral shape formed, nor how long it will persist. Spiral arms aren't stable fixtures, they're density waves, regions where stars bunch together like traffic jams on a cosmic freeway. But what causes these waves to appear and disappear over millions of years? The theories are many, but certainty escapes us. The Milky Way is full of ancient stars, some older than the galaxy itself. That alone presents a puzzle. How can a star be older than the environment in which it resides? The answer lies in galactic cannibalism. Our galaxy is a predator. Over billions of years, it has absorbed smaller galaxies, stripping them of their stars and adding them to its own population. The remnants of these swallowed galaxies remain as faint stellar streams, weaving ghost-like through the Milky Way's halo. These streams are relics of ancient collisions, each telling a tale of cosmic violence and survival. And there are more mergers to come. The Andromeda Galaxy is on a collision course with the Milky Way, and in about 4 billion years, the two will crash together to form a new galaxy, Milkomeda, as some call it. But our galaxy holds mysteries that go even deeper, into the realm of the invisible. Around 85% of the mass of the Milky Way is made of something we cannot see, touch, or detect directly. Dark matter. It does not emit or absorb light. It makes itself known only through its gravitational influence. Galaxies spin faster than their visible matter would allow. Without dark matter, the Milky Way would fly apart. It's the invisible scaffolding upon which our galaxy hangs. But what is it? Particle physicists have proposed candidates: WIMPs, actions, sterile neutrinos, but decades of experiments have failed to catch even a whisper of dark matter directly. Could it be that our understanding of gravity itself is flawed? Some scientists think so, proposing modified theories of gravity, such as MOND, modified Newtonian dynamics, but those too struggle to match observation. We are chasing shadows. As if that weren't enough, above and beyond dark matter lurks an even stranger concept: dark energy. While dark matter holds galaxies together, dark energy is tearing the universe apart. In the late 1990s, astronomers discovered that the universe's expansion was accelerating, a revelation that earned a Nobel Prize and shattered our assumptions. The cause of this acceleration is unknown, attributed to dark energy, an invisible pressure suffusing the vacuum of space. In the Milky Way, dark energy's influence is minimal due to the dominance of gravity at local scales, but across the cosmos, it defines the future. Will dark energy grow stronger and rip galaxies apart in a big rip? Or will it fade, allowing the universe to collapse in a big crunch? We don't know. We don't even know if dark energy is constant or evolving. Even time behaves strangely in our galaxy. Near the supermassive black hole at its center, space-time curves so intensely that time slows down relative to the rest of the galaxy. A clock on a spaceship skimming the event horizon would tick more slowly than one here on Earth. This isn't science fiction. It's Einstein's theory of general relativity in action. We've seen it confirmed in the orbits of stars like S2, which swings around Sagittarius A every 16 years, moving at speeds of up to 3% the speed of light. But while these stars trace elegant loops, others seem to vanish entirely. Some are torn apart by tidal forces. Others plunge directly into the black hole, never to be seen again. But perhaps the most haunting question is, could something be coming out of the black hole? Hawking radiation suggests black holes can evaporate slowly over eons, leaking mass through quantum effects at their boundaries. But others propose more radical ideas: white holes, the theoretical opposite of black holes, which eject matter instead of consuming it. Could the center of our galaxy connect to another universe through a wormhole? Is Sagittarius a one-way portal, or a two-way bridge? These are not accepted theories, but tantalizing possibilities being explored at the frontier of physics. And yet, perhaps the strangest part of our galaxy is not what we can't see, but what we haven't found: intelligent life. The Milky Way is teeming with planets. Thanks to missions like Kepler and TESS, we know there are likely more planets than stars. Many reside in habitable zones, regions where liquid water could exist. Some are Earth-sized, rocky, and orbit-stable, long-lived stars. Statistically, life should be abundant. And yet, the silence is deafening. This is the Fermi Paradox in full force. Where is everyone? Are we early? Are we alone? Or are we being watched? Some posit the existence of Type 3 civilizations, able to harness the energy of entire galaxies, but we've seen no Dyson spheres, no interstellar beacons, no megastructures. Could they be hiding? Could they have wiped themselves out? Could they be here, but undetectable to us? The idea of a galactic zoo, where Earth is deliberately left alone, has been considered. Perhaps we are under quarantine. Or perhaps we are the first. Radio telescopes listen intently to the void. Occasionally, they hear something: a fast radio burst, a wow signal, a repeating blip from an unknown source. But none have yet been proven to be artificial. Still, the search continues, driven by the hope that the cosmos may yet whisper back. The Milky Way itself whispers to us in other ways. Its rotation curve, its halo stars, its gamma-ray bubbles. Enormous columns of high-energy particles extend above and below the galactic plane, Fermi bubbles, stretching 25,000 light-years each. Their origin is uncertain. Perhaps they are relics of past activity from the central black hole. Perhaps they are echoes of a galactic wind, or the aftermath of long-extinct starburst regions. Their presence suggests our galaxy is not static, but alive, breathing, changing, erupting over cosmic timescales. Somewhere between the arms of the Milky Way, floating through interstellar space, there exists a kind of loneliness that even our most powerful instruments can't penetrate. It's not the silence of a vacuum, nor the darkness between stars. It's the unanswered question that has haunted humanity since the first spark of consciousness. Why are we here? And if we are here, drifting on a pale blue speck in one arm of a spiral galaxy, then what else is out there? The more we understand about the Milky Way, the more this question deepens, forming a void of its own. Every time we point our telescopes outward, we uncover another layer of this mystery. Consider the galactic halo, a vast, nearly spherical region that surrounds the Milky Way. It is composed of older stars, globular clusters, and, mysteriously, an abundance of dark matter. This halo extends far beyond the visible disk of the galaxy and is largely invisible to the naked eye. The stars here are ancient, relics from the earliest days of galactic formation, and their distribution hints at a chaotic past. It's here, in this dim expanse, that scientists have discovered remnants of dwarf galaxies consumed by the Milky Way in a cosmic feeding frenzy. One of the most notable of these is the Sagittarius dwarf spheroidal galaxy, currently in the process of being torn apart and absorbed. Our galaxy is not a static or isolated object. It is in motion, twisting, turning, colliding, and consuming. And it's not alone. Orbiting the Milky Way are dozens of satellite galaxies, tiny, irregular companions like the large and small Magellanic Clouds. These satellite galaxies not only orbit our own but are also interacting with each other, creating long trails of gas and stars across the night sky. These trails are not random. They are the evidence of gravitational battles, tidal forces stretching and stripping matter in elegant, devastating arcs. They also serve as a reminder that even at the galactic scale, nature is both artist and destroyer. Beneath this grand violence, star formation carries on, quietly but relentlessly. Within the spiral arms, vast clouds of hydrogen gas collapse under their own gravity to ignite the birth of new stars. Stellar nurseries like the Orion Nebula are vibrant cradles of life, if not life itself, then at least its raw materials. Here, dust and gas swirl in patterns dictated by forces far beyond our comprehension, and stars are born in clusters, illuminating the darkness around them with ultraviolet fire. Yet not all stars are destined for long lives. The galaxy also hosts its share of cosmic horrors: supernovae, neutron stars, and black holes. A single supernova releases more energy in a few weeks than our Sun will emit in its entire lifetime. These explosions are not just destructive, they're creative. They scatter heavy elements like iron, gold, and uranium into the interstellar medium, elements essential to planets, technology, and biology. Every atom of iron in your blood was forged in the heart of a dying star. You are, in the most literal sense, made of stars. Among the stellar graveyards of the Milky Way, there are even stranger objects. Pulsars, for example, rotating neutron stars that emit beams of radiation like cosmic lighthouses. Some spin hundreds of times per second, their magnetic fields thousands of times stronger than Earth's. They are precise, like atomic clocks, and we can detect their rhythmic pulses from thousands of light-years away. But even these predictable beacons hold secrets. Occasionally, pulsars glitch, change their rotation rates, or emit strange bursts of radio waves that defy explanation. Then there are magnetars, rare, ultramagnetic neutron stars that release powerful flares of X-rays and gamma rays. In 2004, a flare from the magnetar SGR 1806-20, located 50,000 light-years away, temporarily ionized Earth's upper atmosphere. Had it been closer, it might have stripped our planet of its ozone layer. That such power exists within our own galaxy, and so silently, is both humbling and terrifying. But terror isn't reserved just for exotic stellar corpses. Even seemingly ordinary stars harbor mysteries. Take our own Sun, for instance. It orbits the center of the Milky Way every 230 million years, dragging the solar system with it in a vast, elliptical path. This journey is not without consequence. Some scientists have proposed that as the Sun passes through dense regions of the galaxy, such as spiral arms or dark matter clumps, it might disturb the Oort cloud, a theoretical shell of icy objects surrounding the solar system, and send comets hurtling toward the inner planets. Some even link this galactic motion to mass extinction events on Earth, suggesting that the death of the dinosaurs may have had a celestial cause far beyond Earth's atmosphere. And what of the unexplained signals that occasionally whisper through our telescopes? Fast radio bursts, FRBs, have puzzled scientists for over a decade. These are ultra-brief, ultra-powerful radio pulses that last only milliseconds but release as much energy as the Sun emits in days. Some come from billions of light-years away, but others, bafflingly, originate within our own galaxy. A 2020 detection traced one FRB to a magnetar in the Milky Way, confirming at least one possible source. But many FRBs remain unexplained, and some repeat in mysterious patterns, suggesting a yet unknown astrophysical mechanism, or something else entirely. Then there is the galactic center, the most enigmatic and active region of the Milky Way. It teems with radio waves, X-rays, and gamma rays, producing phenomena unlike anywhere else in the galaxy. Just recently, astronomers have observed mysterious structures, massive radio filaments, stretching for hundreds of light-years perpendicular to the galactic plane. Their origin is unknown. They might be magnetic phenomena, or the remnants of ancient jets from the central black hole. They might be related to the same process that created the Fermi bubbles. They might even be something we haven't thought to imagine. Stranger still, this same region emits a peculiar gamma-ray glow called the galactic center excess. It's too intense to be explained by known astrophysical sources. Some researchers believe it could be the signature of dark matter annihilation, particles colliding and converting into energy. If true, it would be the first direct evidence of dark matter. But others argue it could be the result of a population of undetected millisecond pulsars. The truth remains hidden. And so we come back to the question of what lies unseen. For everything we can observe in the Milky Way, its billions of stars, nebulae, planets, black holes, and supernovae, there is more that lies hidden. The interstellar medium, for example, is not empty space, but a complex soup of gas, plasma, and dust, all interacting with magnetic fields, radiation, and stellar winds. Within it lie molecular clouds, cold, dense regions where chemistry flourishes. Some of these clouds contain complex organic molecules, including precursors to amino acids. These are the seeds of biology, scattered like confetti through the arms of the galaxy. They remind us that life might not be unique to Earth, that the same processes that created us could be at work elsewhere. The Milky Way is also full of rogue planets, worlds not tethered to any star, wandering the galactic night alone. Recent studies suggest there may be billions of such orphan planets in our galaxy. Some may have been ejected from their home systems during violent gravitational interactions. Others may have formed in isolation. Could some of these planets harbor subsurface oceans, warmed by internal heat, perhaps even life? We simply don't know. But their existence expands the definition of what a planet can be, and challenges our ideas about where life might arise. Even more radical are the hypotheses that the Milky Way itself might be part of a larger cosmic structure that defies current models. The idea of the cosmic web, a vast, filamentary structure of galaxies, dark matter, and voids, suggests that our galaxy is but a single node in an interconnected tapestry stretching across the universe. Some physicists propose that fluctuations in this web might influence the behavior of galaxies, or even hint at the existence of parallel universes exerting subtle gravitational effects on our own. And if parallel universes exist, if the multiverse is real, then our Milky Way may not be unique at all. Somewhere, in a reality just adjacent to ours, there could be another Milky Way, another Earth, another you. Or perhaps in some realities, the galaxy never formed at all. The implications are staggering. Our place within the Milky Way is humble. We reside in the Orion Arm, a minor spiral spur between the larger Sagittarius and Perseus arms, about 27,000 light-years from the galactic center. From here, we look outward and inward, and sometimes we catch glimpses of profound truth. But more often, we are reminded of our ignorance. For every question we answer, 10 more arise. The galaxy does not surrender its secrets easily. Yet it does speak. In the cold hum of microwave background radiation. In the bursts of pulsars and the slow drift of stars. In the gravitational warping of starlight around invisible masses. In the chemical signatures of distant atmospheres. It speaks, not in words, but in numbers, patterns, anomalies, and light. And we, fragile, curious, momentary, are just beginning to listen. But what happens when we begin to truly listen, not just to the loudest signals, the brightest explosions, or the clearest patterns, but to the silences, the voids, the dark spaces between what we understand? The Milky Way is not just a source of cosmic wonder because of what it reveals, but also because of what it stubbornly hides. For every pulsar that pulses with predictable rhythm, there's a silent neutron star, undetectable by current instruments. For every cloud of glowing hydrogen that marks a nursery of stars, there are cold, quiet regions where gravity conspires to create without light or witness. In recent years, astronomers have begun exploring the dark forest theory of cosmic silence, derived from a haunting analogy. Imagine a forest filled with hidden civilizations. Each one stays silent, concealed, terrified that to reveal itself would mean destruction by another, more advanced predator. The Milky Way, in this analogy, is not quiet because it's empty, but because it's afraid. Could this explain the eerie silence of the galactic radio spectrum? Might civilizations, if they exist, have learned to cloak their energy output, to encrypt their transmissions, to disappear from detection? In a galaxy as ancient as ours, where civilizations could rise and fall millions of years before humanity even evolved, the absence of evidence is not evidence of absence, it is only a further deepening of the mystery. Then there's the phenomenon of galactic archaeology, a field where astronomers reconstruct the history of the Milky Way by studying the chemical fingerprints of stars. Every star carries the imprint of its birth environment, its metallicity, its elemental composition, its age. By mapping these across the galaxy, scientists have begun to reconstruct the grand collisions, mergers, and disruptions that shaped our spiral home. One such discovery was the Gaia-Enceladus event, a colossal galactic merger that occurred billions of years ago. The evidence? A population of stars moving differently than the rest, like a fossil record of ancient trauma embedded in the galaxy's very bones. This merging, this cannibalism, is not an exception but a rule. Our galaxy is growing by devouring others. And one day, as mentioned earlier, it will meet its equal, Andromeda. Already on a collision course, Andromeda approaches at 110 kilometers per second. The impact won't be a sudden crash, but a slow, gravitationally driven dance lasting billions of years. Galaxies will pass through each other. Stars will be flung into new orbits. Black holes may merge. In the end, a new elliptical galaxy will emerge, vast, radiant, and utterly transformed. Earth, if it survives, will witness night skies filled with cascading rivers of stars, brighter than any our ancestors could ever have imagined. And in all this drama, there is still the human element. For while the stars move on scales of millions and billions of years, our time is short. A blink. Yet somehow, we have gained the capacity to look across these cosmic chasms and piece together stories. We, who were once terrified of the dark, now build observatories in deserts and mountaintops and orbit, reaching beyond our little planet, driven not by survival, but by wonder. The Milky Way has become not just a place we inhabit, but a subject we question, as if the galaxy itself were a mirror, showing us who we are. From this mirror, we learn strange truths. One of the most haunting is that the galaxy itself may one day go dark. The stars, all of them, will eventually die. Even red dwarfs, the longest living stars, will fade to cold embers. The black holes will consume what they can, and then evaporate through Hawking radiation. Over unimaginable spans of time, the galaxy will become a graveyard of faint, cold remnants, white dwarfs, neutron stars, black holes, drifting in silence. And yet, from this decay may come something new. Some physicists speculate that the death of a universe could seed the birth of another, a kind of cosmic rebirth on a scale beyond comprehension. Even as we ponder this ultimate entropy, there are whispers of renewal. Star formation continues. Molecular clouds still collapse. Life, at least on Earth, persists. And it is in this persistence that perhaps the greatest mystery of the Milky Way lies, not in black holes or dark matter, but in the spark of life that emerged on a small rocky planet orbiting a modest yellow star. How? Why? What precise conditions conspired to turn chemistry into biology, and biology into consciousness? The Milky Way is 13.6 billion years old. Life on Earth began around 3.8 billion years ago. Was this timing rare, a statistical fluke? Or is life an inevitable product of galactic evolution? The answer may lie in the exoplanets. Thousands have been discovered, and tens of thousands more are waiting. Some orbit close to their stars, locked in tidal embrace. Others lie in perfect temperate zones. A few orbit multiple stars, experiencing sunrises and sunsets unlike anything imaginable. In these alien worlds, with their exotic atmospheres and complex dynamics, could microbial life flourish? Could intelligence evolve? Could civilizations rise and fall, building monuments of light, then vanishing without a trace? And how would we even know? Our current methods of detection, transit photometry, radial velocity, direct imaging, are astonishingly advanced, yet still crude compared to the scale of the galaxy. A planet the size of Earth, orbiting a sun-like star 1,000 light-years away, is almost impossible to detect with certainty. Yet within just that narrow slice of space could lie thousands of Earth-like worlds. And within those, billions of microbial ecosystems, perhaps even civilizations that have come and gone without ever sending a single signal our way. Meanwhile, closer to home, we continue to look inward. Toward Europa, Enceladus, Titan, moons in our own solar system with subsurface oceans, organic molecules, and the potential for alien life. These are the stepping stones to galactic understanding. If life is found here, under the ice of a Jovian moon, it would change everything. It would suggest that life is not a miracle, but a galactic pattern, a natural consequence of physics, chemistry, and time. But if we find nothing, no bacteria, no fossils, no biochemistry, then the mystery only deepens. We are left to ask whether something truly unique happened here, in our tiny corner of the Milky Way. And if so, what does that say about our responsibility to the galaxy? Are we its only conscious voice, its first self-aware creation? If that is the case, then the weight of that realization is staggering. We are not just observers, but participants, perhaps even caretakers, of a galactic legacy billions of years in the making. And so we build. We plan missions to other stars, Proxima Centauri, Tau Ceti, TRAPPIST-1. We design probes that may one day traverse interstellar space, carrying with them fragments of our civilization. Images, sounds, languages, dreams. The Voyager probes have already left the solar system, bearing golden records etched with music, greetings, and scientific knowledge. They drift now in the interstellar medium, silent ambassadors from Earth, their destinations unknown. In the decades to come, telescopes like the James Webb Space Telescope and its successors will look deeper into the Milky Way than ever before. They will peer into star-forming regions obscured by dust, decode the atmospheres of exoplanets, and perhaps glimpse the chemical fingerprints of life. Instruments will grow more sensitive. Data will multiply. The universe will, slowly, begin to yield. But the greatest instrument we possess is not made of mirrors or silicon. It is the human mind. It is our curiosity, our defiance of ignorance, our hunger to know. We are the galaxy learning to know itself. We are born of its stars, shaped by its physics, driven by its mysteries. And as we map its arms, its center, its halo, we are not just making charts, we are writing a story. One whose next chapter is always unknown, whose ending will never be final. The Milky Way remains silent, but not indifferent. It is ancient, patient, and far more complex than we can grasp. Its mysteries are not puzzles to be solved, but invitations to deeper questions. Every black hole, every pulsar, every rogue planet is a verse in a galactic poem we are just beginning to translate. We look up, not for answers, but for the wonder that makes answers worth pursuing. We are wanderers of the spiral, seekers of the unseen, listeners to the silence. And though we may never reach the edges of this vast and beautiful mystery, we will keep moving, keep asking, keep dreaming, because in doing so, we become something greater than the sum of our stardust parts. We become the voice of the Milky Way itself. The voice of the Milky Way speaks not in a single language but in countless dialects of energy, motion, light, and gravity. It speaks through the bending of starlight around invisible masses, through the echo of ancient explosions reverberating across the galactic disk, through the intricate orbits of stars near the supermassive black hole, and through the cosmic microwave background that bathes our galaxy in the afterglow of the Big Bang. But more than anything, it speaks through the questions it inspires. Questions that don't fade with time but deepen, becoming more profound with every advancement in our understanding. And what do we do in response? We build observatories on the edges of extinction, on the cold summits of dormant volcanoes, in orbit around Earth, and soon, perhaps, on the far side of the Moon, places shielded from the noise of civilization so we can better hear the whispers of the galaxy. We build massive arrays of radio telescopes that stretch across continents. We study gravitational waves, ripples in spacetime caused by violent events like black hole mergers, and begin to hear the galaxy not just in light, but in the very fabric of reality. Consider for a moment that gravitational wave astronomy is still in its infancy. And yet, it has already confirmed the existence of binary black hole collisions and neutron star mergers. These are cataclysmic events that release more energy in a few seconds than all the stars in the galaxy combined during that time. And they happen right here in the Milky Way. invisible, ongoing, until recently, unknowable. These events forge heavy elements, gold, platinum, uranium, and fling them across interstellar space. Your wedding ring, the metal in your electronics, all of it, forged in ancient, violent stellar deaths. These cosmic collisions also offer us new ways to test the laws of physics. Do gravitational waves travel at the speed of light? So far, yes. Are they distorted by dark matter or dark energy? We're still checking. Could they reveal deviations from general relativity, offering clues about quantum gravity or extra dimensions? Possibly. Every ripple from a dying star is another data point in our quest to unify the cosmos. Then there is time, our most human obsession. The Milky Way challenges our concept of it at every level. Stars live for billions of years, drifting slowly across the sky. Light from distant regions of the galaxy takes tens of thousands of years to reach us. We see the past in every direction. Some of the light entering your eyes tonight may have begun its journey when humans were still painting the walls of caves. In this sense, the night sky is not a view, it is a time machine, a window into epochs we will never experience, but can still observe. This connection to time also forces us to confront our own impermanence. Humanity is but a flicker in the long history of the Milky Way. A galactic year, the time it takes the Sun to orbit the center of the galaxy, is about 230 million Earth years. We've made this journey only once since the age of the dinosaurs. In that time, continents drifted, mountains rose, species came and went. And yet, here we are, conscious, curious, and just beginning to grasp our place in this swirling wheel of stars. In fact, our planet and solar system are perfectly poised for observation. Earth sits within a relatively calm and safe region of the galaxy, not too close to the chaotic center, not too far out in the sparsely populated edges. This galactic habitable zone is where conditions may be just right for complex life to develop. Too close to the center, and you're bombarded by supernovae and radiation. Too far, and you lack the heavy elements needed for rocky planets and complex chemistry. Could it be mere coincidence that intelligent life arose in this narrow band of galactic real estate? Or is this evidence of a deeper pattern, a kind of cosmic selection? Some scientists propose the rare Earth hypothesis, which suggests that while microbial life might be common, the evolution of intelligent life requires such a precise and improbable combination of factors that it may be nearly unique. Others counter with the mediocrity principle, which holds that there's nothing particularly special about Earth, and that similar planets, and perhaps civilizations, must exist elsewhere in the galaxy. The truth, for now, remains elusive. But one thing is certain, the Milky Way has had over 13 billion years to experiment. The odds of us being the only result seem vanishingly small. Our search for answers continues in the most ambitious ways. We are mapping the entire structure of the galaxy in 3 dimensions. The European Space Agency's Gaia mission has already catalogued the positions and motions of over 2 billion stars. With this data, astronomers can reconstruct not just the present state of the Milky Way, but its past and future. We can trace how stars move, how clusters form, how the spiral arms twist and dissolve. We can even predict close stellar encounters, stars that may pass within a few light-years of Earth in the distant future, potentially disturbing the Oort cloud and sending comets inward. Even now, there are stars on their way. One such star, Gliese 710, is expected to pass through the outer edge of our solar system in about 1.3 million years. Its gravitational influence could send a cascade of icy objects toward the inner planets. This won't be a cataclysm, but it could be a cosmic reshuffling, a reminder that even the quiet periphery of the galaxy is alive with motion. And all the while, we continue to dream. Projects like Breakthrough Starshot aim to send tiny, light-driven probes to nearby stars, Alpha Centauri, just 4.37 light-years away. The goal is to make the journey in a few decades, transmitting images and data back to Earth. It would be humanity's first true step into interstellar exploration. Imagine the moment when we receive the first images of another solar system. Planets orbiting a foreign star, seen not through a telescope, but through a machine we built and launched into the galaxy. But why stop there? The galaxy is filled with wonders we haven't even begun to reach. Giant molecular clouds hundreds of light-years across, filled with the raw materials for star and planet formation. Stellar nurseries where dozens of suns are born from the same collapsing cloud. Massive star clusters with thousands of tightly packed stars, some of which may have already developed planetary systems. And then there are the forbidden regions, the galactic bulge, the halo, and the edge of the disk, regions where conditions differ wildly from our own. What kinds of stars, planets, and maybe even life might exist in those corners of the galaxy? Could silicon-based life forms evolve in high-temperature environments? Could plasma-based life exist in the magnetic fields of neutron stars? These ideas sound like science fiction, but they are grounded in serious speculation by leading astrobiologists and physicists. Even the fundamental structure of the Milky Way remains uncertain. While it's traditionally described as a barred spiral galaxy, recent observations suggest that its spiral arms may be transient features, waves of density, not fixed structures. The bar at the center, an elongated group of stars crossing the core, seems to rotate, possibly influencing the formation of new arms and the motion of stars throughout the disk. The whole system is in flux, a constantly changing whirlpool of matter, energy, and time. And beyond the Milky Way, there are other clues. When we look at other galaxies, we see echoes of our own. Some are larger, more structured, with prominent arms and brilliant cores. Others are small, irregular, or warped by past collisions. Some have active nuclei, supermassive black holes devouring matter and emitting intense radiation. Others are quiet, dark, and fading. Each one tells a part of the story of galactic evolution, a story in which the Milky Way is just one chapter. But this chapter is ours. We live within it. We are woven into its plot. And though we may be small, we are not insignificant. For we are the only part of the Milky Way, so far as we know, that reflects on itself. That builds machines to trace the stars. That writes symphonies, stories, and equations in an attempt to translate the language of the cosmos. As Carl Sagan once said, we are a way for the universe to know itself. If that is true, then we are also the Milky Way's memory, its voice, its question, and its hope. The stars burn, the planets turn, the black holes sleep and awaken, but only here, on this small world, have they come together to wonder why. And we will keep wondering. We will keep looking. Because the mystery of the Milky Way is not one that frightens us, it draws us in. It makes us poets and physicists, engineers and dreamers. It gives us something that no other force in the galaxy can: purpose. Purpose, that elusive, intangible force that drives everything from the earliest cave paintings to the most complex orbital observatories. In a universe governed by entropy and expansion, purpose is a human creation, forged not from necessity, but from wonder. And in the face of the Milky Way's incomprehensible scale and age, the fact that we continue to search for meaning is, in itself, a kind of miracle. We are temporary creatures searching for permanent truths, and somehow, the galaxy rewards our curiosity with glimpses, faint, fleeting, and often paradoxical, of something greater. Even the starlight we see is a kind of deception, a ghost of what was. When we observe a star 1,000 light-years away, we are seeing it as it was 1,000 years ago. For all we know, it may have already gone supernova, collapsed into a black hole, or faded into a white dwarf. The night sky is not a view of the present, it is a map of the past, layered with countless epochs. Every star is a window into a different time. And we, by simply looking up, are collecting stories written long before our species existed. This fact adds a strange kind of intimacy to the stars. They are not just distant balls of gas, they are messengers of ancient light, part of an ongoing conversation between the past and the present. Some of these stars, we now know, host planets. Some of those planets lie within habitable zones. And some of those might harbor life. We don't yet know how to detect life conclusively from such distances, but we are getting closer. Atmospheric spectroscopy, the science of analyzing the light that passes through a planet's atmosphere, has already revealed the presence of water vapor, methane, carbon dioxide, and other molecules on distant worlds. One day, perhaps soon, we may detect biosignatures, chemical evidence of life. But even biosignatures are not enough. They tell us only that life might exist. They don't reveal its complexity, its intelligence, or its story. For that, we need something more, a signal, a structure, an artifact. Something that says not only we are here, but we know. And that's why we listen. Why massive radio telescopes like the Square Kilometre Array and the Allen Telescope Array scan the sky for artificial signals. Why the SETI Institute continues to sift through cosmic noise in search of that one, impossible hello. And in this search lies another mystery, the Great Silence. Despite all our efforts, despite the mathematical probability of life, the galaxy has yet to send us an unambiguous signal. This silence has led to countless theories: the rare Earth hypothesis, the Great Filter, the Dark Forest, the Transcension hypothesis. Some posit that intelligent civilizations destroy themselves. Others believe they evolve beyond the need to communicate. Still others think we're simply not looking in the right way, or that the signals are there, but indistinguishable from nature. It's a profound and sobering possibility that we may be surrounded by civilizations we'll never detect, either because their technology is too advanced, too subtle, or too different. They may not use radio waves. They may encode their knowledge in gravitational waves, neutrinos, or quantum entanglement. Or they may live in virtual realities so complete they no longer care about the external galaxy. And yet, we keep listening. Why? Because the act of listening is as important as the message itself. It affirms that we are open, that we are ready, that we are not afraid to know we are not alone, or that we are. The search gives shape to our place in the galaxy. It pushes our technology, challenges our philosophy, and binds us together in a common cause that transcends. Meanwhile, the Milky Way moves on. It turns slowly, pulling stars and gas along its arms, spiraling toward a fate we can barely imagine. The stars burn and die, the planets orbit in silence, and gravity continues its invisible ballet. And here, on a small planet orbiting an average star, a species only recently aware of its galactic context continues to learn. Our future in this galaxy is still unwritten. Will we become a multi-planet civilization? Will we send ships to other stars? Will we colonize Mars, the moons of Jupiter, the icy rocks of the Kuiper Belt? Or will we turn inward, perfecting life on Earth and turning our gaze more fully to the stars, not as conquerors, but as students? Some thinkers imagine vast space habitats, O'Neill cylinders, Dyson swarms, entire megastructures capable of housing trillions of beings orbiting stars. Such ideas may seem like science fiction now, but so did space travel a century ago. As our energy needs grow, so too will our reach. Perhaps the Milky Way will one day be dotted with human or post-human civilizations, spread across thousands of systems, connected by communication networks and interstellar archives of knowledge. But such a future depends not only on technology, but on wisdom. To survive long enough to join the stars, we must first learn to live sustainably on our home world. The Milky Way does not grant second chances lightly. Supernovae do not care. Gamma-ray bursts are indifferent to ambition. To last, we must become stewards, not just of Earth, but of ourselves. The galaxy, in all its immensity, does not owe us a future. It offers only opportunities and silence. The rest is up to us. Still, one cannot help but imagine what it would be like to travel across the Milky Way. To see its spiral arms from outside. To navigate through its halo, to plunge into its central bulge, to orbit Sagittarius A and witness the stars whipping around the abyss at breakneck speeds. Perhaps one day, autonomous probes will do just that. They will map every cluster, catalog every nebula, and bring us data so rich we'll spend centuries decoding it. Perhaps even our consciousness will travel, uploaded, transmitted, reborn in synthetic vessels capable of withstanding the void. The galaxy may become our playground, our archive, our final home. But whether we remain biological or become something else, our essence will still be the same: curiosity, creativity, consciousness. And so we return, always, to the mystery. The Milky Way is not just a collection of stars and gas. It is a story, a billion stories, woven together by gravity and time. It is both ancient and ever new. And while its edges may lie 50,000 light-years away, its true frontier is within us. In our willingness to ask questions we can't yet answer, to dream of journeys we can't yet take, to imagine futures we may never live to see. But someone will. Some distant descendant. Some mind, human or otherwise, will one day look back at Earth, not as the center of the universe, but as the beginning of a journey. The spark that lit the fire. The whisper that became a song. And the Milky Way will still be turning. Silent. Majestic. Eternal. Long after our cities have crumbled and our monuments have faded into dust, the stars will remain, drifting slowly along their galactic paths, bound to the invisible gravitational rhythms of the Milky Way. Long after our languages have evolved beyond recognition or vanished entirely, the story of our existence will still echo in the photons we've sent outward, in the relics we leave behind, spacecraft frozen in interstellar flight, signals bouncing endlessly through the void. We may vanish, but the evidence of our wonder, our curiosity, our longing to connect, may linger. Imagine, for a moment, a future intelligence, perhaps not human, detecting the faint radio echo of our civilization, long after we are gone. A pulse of artificial structure in the galactic noise. A pattern that defies randomness. And with it, a message: we were here. We looked up. We tried to understand. That alone might make our brief presence meaningful. But our goal isn't merely to be remembered. It's to understand. And understanding, in a galaxy like this, is a lifelong pursuit, stretching far beyond lifetimes, generations, or even civilizations. Each new answer leads to 10 new questions. Each layer of truth reveals deeper uncertainties. The Milky Way is a cosmic puzzle with no final solution, only ever-expanding depth. Take, for example, the recent discovery of strange stars that appear too old to exist. Some stars in the halo of the Milky Way seem to predate the galaxy itself, according to their age estimations based on radioactive decay. While this might be a calibration error, it has forced astronomers to reconsider long-held assumptions about stellar formation, galactic mergers, and even the rate of cosmic expansion. Could these stars be remnants of an even older structure? A pre-Milky Way galaxy that was consumed in the early chaos of galactic assembly? Or are we glimpsing some exotic, ancient physics that our current models can't yet explain? And what of the stars that don't behave? Hypervelocity stars, for instance, those ejected from the galactic core at speeds high enough to eventually escape the Milky Way's gravitational pull. How do they get launched at such astonishing velocities? One explanation involves close encounters with the supermassive black hole, where binary star systems are torn apart, one star captured, the other flung outward like a slingshot. These rogue stars are cosmic messengers, carrying with them information about the extreme environments of the galactic center, written into their trajectories and spectra. Then there are the galactic anomalies that baffle even seasoned astrophysicists. Massive cold gas clouds moving in directions contrary to the rotation of the galactic disk. Mysterious gamma-ray signals with no obvious source. Planetary systems around dead stars, white dwarfs, with intact orbits, hinting at the resilience of planetary architecture even in the wake of stellar death. All these phenomena add to the evolving portrait of a galaxy far more complex, nuanced, and dynamic than our textbooks suggest. We often speak of the Milky Way as a single object, but it is better understood as a collection of vastly different environments, stitched together by gravity and time. The calm, orderly rotation of the outer disk gives way to the chaotic churn of the inner regions. The spiral arms pulse. With new star formation, while the halo floats in ghostly quiet, home to ancient stars and globular clusters. The galactic bulge, dense and turbulent, contrasts with the vast, diffuse corona of hot gas that extends far beyond the visible structure. This outer halo, filled with ionized plasma, may be the galaxy's true boundary, a colossal, spherical field tens of thousands of light-years wide, still largely unexplored. In recent years, attention has turned to this galactic corona. It may be the key to solving one of astrophysics' biggest mysteries, the missing baryon problem. Based on models of the early universe and cosmic background radiation, there should be more normal matter in galaxies like ours than what we currently observe. A large fraction of it may be hiding in the hot, diffuse halo surrounding the Milky Way, nearly invisible to most telescopes, detectable only through the faint absorption lines it leaves in the light of distant quasars. If confirmed, this would not only fill a massive gap in our understanding, but redefine the scale and structure of our galaxy. It's not just large-scale features that surprise us. At the microcosmic level, we're beginning to see patterns we don't fully understand. For instance, there are stars that flicker or dim in ways that defy all known models of stellar variability. The most famous of these is Tabby's star, which exhibited an irregular dimming pattern so unusual that it sparked worldwide speculation, including the hypothesis of an alien megastructure blocking its light. While more mundane explanations like dust clouds are more likely, the very fact that such behavior can exist shows how much we still have to learn. We've also started to detect planets in astonishing configurations. Hot Jupiters orbiting so close to their stars that their atmospheres are boiling off, super-Earths with lava oceans, rogue planets the size of Neptune drifting alone in the cold dark, and circumbinary planets orbiting two suns like something out of a myth. These discoveries show that planetary systems are far more diverse and dynamic than our own solar system might suggest. And with each new planet catalogued, the probability of life-sustaining worlds grows. Indeed, one of the greatest recent developments is the recognition of the galactic habitable zone, a theoretical band within the Milky Way where the conditions are just right for complex life to evolve. Not too close to the center, where radiation and gravitational interactions are deadly, and not too far out, where heavy elements may be too scarce. Earth lies squarely in this zone. Coincidence? Maybe. But maybe not. Perhaps galactic ecology, like planetary ecology, is real, and certain regions of the galaxy are more conducive to life, just as certain regions of Earth support denser biodiversity. This notion opens up tantalizing possibilities. Could there be galactic ecosystems? Zones where life is more likely to flourish, or even communicate? Regions of space where civilizations rise and fall more frequently? Could advanced life emerge, go dormant, or migrate in patterns across the galactic disk, driven by factors we have yet to consider, such as supernova proximity, metal abundance, or even galactic magnetic cycles? The Milky Way, after all, is not static. It breathes. It moves. It changes. Spiral arms shift. Stars migrate. The entire disk oscillates like a ripple in a pond, moving up and down relative to the galactic plane. This motion may even influence the climate of Earth. Some theories suggest that our solar system's passage through galactic dust clouds or dense regions might correlate with mass extinctions or ice ages. If true, it would mean that not only does Earth shape life, but the galaxy itself may be subtly shaping Earth. And still, despite everything, we have only scratched the surface. The majority of our galaxy remains uncharted. We don't know what lies beyond the dense walls of interstellar dust. We don't fully understand the life cycle of the galactic bar. We haven't solved the enigma of dark matter or touched the truth of dark energy. The very edge of the galaxy, where its influence wanes and intergalactic space begins, is a mystery wrapped in plasma, gas, and forgotten starlight. One day, though, we will go there. Not just with telescopes and equations, but with vessels, with explorers, with sentience. The future will see our children, or their children, navigating the currents of the galactic sea. They will map it not as astronomers, but as travelers. The Milky Way will no longer be an object of observation. It will become a domain of experience, a homeland expanded beyond the bounds of Earth. But that begins now, with us. With curiosity. With awe. With daring to ask questions we have no answers to. Every child who looks up at the stars continues the oldest story ever told, the story of looking beyond. The Milky Way is not just out there. It is within us. Every atom in your body came from its stars. Every thought you've ever had was powered by energy that once lived in a sun. Every heartbeat, every breath, every dream is part of a galactic narrative billions of years in the making. We are the children of the galaxy. And it's time we started acting like it. And as children of the galaxy, we carry within us the dual nature of innocence and ambition, the yearning to explore and the humility to recognize how little we know. The Milky Way is not merely a backdrop to our existence, it is our crucible. It forged the elements that make up our bodies. It guided the trajectories of comets that seeded Earth with water. It provided the quiet, relatively stable arm in which our solar system could form and endure, giving evolution a chance to unfold. And now, after billions of years, it's beginning to sense its own consciousness through us. This is no exaggeration. Consider the fact that for most of its 13.6 billion years of existence, the Milky Way has been silent and blind to itself. Stars burned, supernovae exploded, black holes fed, all without witness or reflection. But now, something extraordinary is happening. The galaxy is beginning to know that it exists. Through the minds of conscious beings, through science and art and the hunger to understand, the Milky Way is peering into its own structure. Every time we build a telescope, we give the galaxy an eye. Every formula we write gives it a language. Every mission we launch becomes a limb reaching further into the unknown. And every time someone, somewhere, looks up at the sky with wonder, the galaxy feels its own mystery stir. This moment in history is not merely a technological one. It's an existential awakening. Humanity has reached a threshold where our questions are no longer just about survival, but about context. Who are we, in relation to all of this? Are we a fluke, a miracle, a starting point? What responsibilities do we bear, now that we can alter the trajectory of life not just on our planet, but possibly on others? What kind of ancestors will we be? Because make no mistake, if we survive the next few centuries and avoid the great filters that may have silenced other civilizations, we will become ancestors to beings who live not just on Earth, but among the stars. Future generations will look back on us the way we look back on the first humans who ventured out of Africa, full of fear and hope, driven by something they couldn't name but couldn't ignore. And they will ask, what did we do with the knowledge we had? Did we use it to preserve our world or exploit it? Did we share it or hoard it? Did we nurture the flame of curiosity, or let it be extinguished by fear, greed, and short-term thinking? The choices we make today ripple outward, not just across time, but across space. Every breakthrough in propulsion, energy, artificial intelligence, or sustainability is a brick laid in the foundation of a galactic future. Every act of peace and cooperation is a vote for a species worthy of that future. Every child taught to wonder is a star ignited. Because to truly explore the galaxy, we will need more than rockets and radiation shields. We will need unity. We will need vision. We will need cultures that value knowledge for its own sake, and systems that reward patience over profit. We will need to redefine what progress means, not merely in terms of speed or output, but in terms of wisdom and resilience. Consider the journey ahead. To cross even the nearest star systems will require energy on a scale we've never harnessed. Concepts like the Alcubierre warp drive, antimatter propulsion, or even solar sails pushed by massive lasers are being explored, but they remain in early stages. We will need to master fusion energy, create closed-loop life support systems, and develop materials that can withstand the rigors of deep space for centuries. More than that, we will need to expand what it means to be human. Will future interstellar travelers be augmented with AI, or even merge with it entirely? Will we send digital consciousness aboard probes, encoded minds that awaken upon arrival? Will we terraform new worlds, or adapt ourselves to thrive on alien soil? These questions are not science fiction, they are strategic foresight. But no matter how we evolve, we will still carry the core spark, the desire to know, to connect, to explore. This is what links us to the galaxy. We are not apart from it. We are its latest experiment in awareness. Its newest lens into its own immensity. And that immensity is humbling. Just consider again the scale. Our solar system lies about 27,000 light-years from the galactic center. If we could travel at the speed of light, something no known object can do without infinite energy, it would still take us tens of thousands of years just to reach the other side of the galaxy. And the Milky Way is only one galaxy among hundreds of billions in the observable universe. Yet within this vastness, we are not irrelevant. In fact, it is because the universe is so vast that our perspective is so valuable. A single conscious mind, capable of looking outward and inward at once, is rarer than any star or planet. The universe, as far as we know, is mostly dark, cold, and unaware. But in us, there is light, warmth, and awareness. We are the exception. And perhaps, the purpose. Some believe this awareness is not just a byproduct of complexity, but a fundamental aspect of the cosmos. Consciousness as a field, a dimension, a hidden symmetry. Others see it as a rare chemical miracle, fragile and improbable. But either way, it's here. And it's growing. The more we look outward into the Milky Way, the more we are forced to look inward as well. To ask what it means to matter in a galaxy so old. What it means to care in a universe so indifferent. What it means to love, create, and imagine, when the stars themselves will one day die. And the answer, perhaps, is that meaning is not given, it is made. Not by galaxies, but by minds. By acts of choice. By stories. The Milky Way does not speak. But we do. And by speaking, by imagining, by daring to reach, we give voice to the silent stars. We become their storytellers. So let us tell a good story. Let it be one of courage, not conquest. Of discovery, not domination. Of listening as much as speaking. Of learning from the stars, not just about them. Let it be a story in which we learn to see the Milky Way not as something to be tamed, but something to be known, and in knowing it, know ourselves. Because in the end, the greatest mystery of the galaxy may not lie in its black holes, its dark matter, or its alien civilizations. The greatest mystery may be this, that in all the cold, vast, silent immensity of space, something woke up. And that something was us. And we didn't just wake up, we began to listen. We tuned our instruments not only to light but to the faintest whispers of the universe, the ripples in spacetime known as gravitational waves, the fleeting neutrino bursts from dying stars, the hiss of cosmic microwave background radiation echoing from the birth of time. Every signal we decode, every anomaly we investigate, every silence we measure is part of a greater dialogue with the galaxy, a conversation that has only just begun. For instance, in recent years we've turned our ears toward the mysterious fast radio bursts, FRBs, short, high-energy pulses of radio waves that originate from far beyond our galaxy. Some of them are one-off events. Others repeat at regular intervals. What causes them? Are they natural phenomena, like magnetars shedding energy, or are they something more? Are we seeing the fingerprints of a natural process we don't yet understand, or is there a sliver of possibility, however small, that we're intercepting distant, intelligent communication? We don't know. And that not knowing is powerful. Because it reminds us that, even with all our instruments and intellect, we're still beginners. We're still learning the language of the stars. The galaxy, after all, is not built for us. It was here long before our atoms ever assembled into thought, and it will be here long after the last of our cities has turned to sand. But in the interim, in this brief, flickering moment that is human existence, we have the unique opportunity to know it. As witnesses. As students. And the Milky Way is a stern teacher, filled with paradox and danger. It shows us beauty in supernova remnants glowing across light years, but reminds us that those same explosions could sterilize worlds. It reveals harmony in the dance of binary stars, but also chaos in the collapse of planetary systems. It gives us the promise of exoplanets with liquid oceans, but cloaks them in lethal radiation or ice. This duality, the sublime and the savage, defines the galaxy. It forces us to evolve not only technologically, but philosophically. We can't just conquer space, we must learn to coexist with it. We must learn patience, persistence, and above all, humility. We must also learn collaboration. The distances involved in galactic exploration are so vast, and the problems so complex, that no single nation or people can manage them alone. To map the stars, we must map our collective will. Projects like the James Webb Space Telescope, the Square Kilometre Array, and Breakthrough Listen already show what we can achieve when we work together. They are the prototypes of a planetary civilization. But imagine what comes next. Not just telescopes and rovers, but swarms of self-replicating probes sent to the farthest reaches of the galaxy. Artificial intelligences trained not just to calculate but to wonder. Dyson swarms capturing the full output of a star. Vast orbital libraries containing the collective knowledge of our species, floating above distant exoplanets like lighthouses. And perhaps, one day, a true galactic archive, a place where all the stories of all the sentient beings from every arm of the galaxy are gathered. A cathedral of memory. A testament to the power of awareness. That vision may seem impossibly distant. But so once did the idea of spaceflight, or lunar landings, or decoding the DNA of life. Progress is not always linear, but it is inevitable, when driven by curiosity. And it is curiosity, more than anything else, that defines our relationship to the Milky Way. Not just a hunger to survive or expand, but to understand, to know. That desire is sacred. It binds us across generations, across cultures, across species. It's what drove our ancestors to chart the heavens with bone and stone. It's what drives our scientists to sift through terabytes of starlight. And it's what will drive our descendants to cross the void between stars. Because eventually, we will go. Whether by generational ships, cryogenic sleep, or uploaded minds riding beams of light, we will reach the outer systems. And there, in the shadow of alien suns, we will plant the seeds of Earth, its biology, its stories, its values. We will weave ourselves into the fabric of the galaxy, not as invaders, but as part of its ongoing narrative. And perhaps, in time, we will meet others who have done the same. That question, are we alone, may be the most profound mystery the Milky Way holds. Despite decades of searching, we have no confirmation of extraterrestrial intelligence. The galaxy is vast, and time is long. Maybe civilizations burn out before they can reach one another. Maybe they hide. Maybe they observe us, silently, waiting. Or maybe, just maybe, we are the first. If that is true, if we are the first intelligent species to arise in this galaxy, then the responsibility upon us is immense. It means we are the opening act of galactic civilization. The prologue. The foundation upon which all future contact, cooperation, or conflict will be based. We must rise to that role. Not with arrogance, but with awareness. Not with conquest, but with care. We must preserve our planet, cherish our diversity, and nurture the values that will make us worthy of the stars. We must treat the galaxy not as a resource to be mined, but as a relationship to be cultivated. Because everything we do echoes. Not just across space, but across time. Our emissions, our transmissions, our footprints on alien worlds, they all become part of the galactic record. What do we want that record to say? Let it say that we loved. That we dreamed. That we looked up, not just for answers, but for inspiration. That we dared to turn the silence of the Milky Way into a symphony. And in that symphony, let us be a note of hope. Let us be a note of hope, resonating not because we were the loudest or the most powerful, but because we were the most determined to listen, to learn, to grow. Because in the grand silence of the galaxy, even the faintest signal, if it carries truth, beauty, and compassion, can endure. And perhaps that's the final truth of the Milky Way's mysteries, that the galaxy, in all its scale and power, in all its forces of destruction and creation, ultimately makes room for the smallest of voices. It holds within its spiral arms not only stars and gas, but the possibility of meaning. It allows fragile things, life, love, thought, to rise and speak, even if only for a moment. But what a moment it is! As we orbit our star, cocooned in a blue world teeming with life, we are already shaping the future of galactic history. Every line of code, every launch, every debate about ethics or direction is part of a cosmic process, our slow but steady awakening. And as we wake, we begin to see the Milky Way not just as a physical structure, but as a mirror. In its countless stars, we see ourselves, born from collapse, forged in fire, striving toward light. In its black holes, we see mystery, the limit of knowledge, the edge of understanding. In its pulsars and quasars, its voids and filaments, we see rhythm and pattern, reminders that even chaos holds structure. And in its silence, we see potential. Because the greatest mystery of the Milky Way may not be what's out there, but what we choose to become in response to it. Will we fall to the same fates that may have silenced other civilizations? Will we burn bright and brief, consumed by our own short-sightedness? Or will we endure, transforming not only our technology, but our very way of being? If we succeed, it will not be because we were the strongest or the smartest. It will be because we chose to imagine more. Because we looked at the stars and saw not just resources, but reflections. Because we learned to balance ambition with reverence. And that journey, if we are bold and wise enough to walk it, will lead us not only deeper into the Milky Way, but deeper into ourselves. So let us go forward, not in fear, but in awe. Let us launch our ships, build our observatories, train our minds. Let us teach the next generation not just how to navigate the galaxy, but how to care for it. Let us inscribe our legacy not on stone, but in starlight. Because one day, far from now, long after this moment has passed, someone, somewhere, will look back. Maybe it will be a child on a distant world. Maybe it will be a synthetic intelligence tracing its roots. Maybe it will be an alien historian, cataloguing the rise of an early galactic species. And they will see us. They will see a species that emerged from a fragile world, bound by gravity to one sun, limited by biology and time. But they will also see what we became. They will see the first sparks of a great fire, the first beats of a great song, the first steps on a road that never ends. Because the galaxy does not end. Nor does the journey. There will always be more to discover, more to ask, more to wonder. The mysteries will never cease. And that is the greatest gift of all. That we are part of something endless. That we belong not to a moment, but to a movement, an unfolding, infinite, sacred exploration. So to the stars, we say, we are coming. Not to conquer. Not to claim. But to learn. To listen. To live. And in that living, to give the Milky Way something it has never had before. A witness. A voice. A soul. The soul of the Milky Way, if such a thing can exist, is not a fixed object or hidden relic buried in the galactic core. It is a phenomenon that emerges when consciousness meets wonder. It manifests not in the black holes or the luminous arms of the galaxy, but in the minds that contemplate them. And right now, in this very age, we are at a threshold where that soul is beginning to take shape. Every long gaze through a telescope, every quiet hour spent simulating particle interactions, every philosophical musing about alien life or galactic purpose adds a brushstroke to a portrait we're still learning how to draw. We are not separate from the Milky Way, we are its newest expression, a momentary bloom of intelligence on one of its countless drifting petals. And while that awareness is young and fragile, it holds the power to change everything. The deeper we peer into the Milky Way's anatomy, the more we realize how little we actually know. Even the basic structure of our galaxy, its precise shape, its total mass, the distribution of its dark matter halo, is the subject of ongoing debate. For centuries, we believed our galaxy was the entire universe, then we realized it was just one among many. Today, we understand it to be a barred spiral, about 100,000 light-years across, containing anywhere from 100 to 400 billion stars, most of which may have planets of their own. But even these numbers are approximations, estimates stitched together from observation and inference, because we cannot step outside the galaxy to get a true view of it. We are inside the system we are trying to measure, like trying to map the shape of the ocean while floating on a single wave. And yet, despite our limited perspective, we persist in asking impossible questions. How did the Milky Way form? How many times has it merged with other galaxies? Are there ancient structures hidden in its halo, remnants of forgotten civilizations or long-dead stars that formed before Earth even existed? Could the galaxy itself be alive in some abstract sense, a colossal network of energy and feedback loops functioning on scales of time and space that defy human comprehension? These aren't idle fantasies. They are real questions posed by serious minds, working from the fringes of physics, cosmology, and systems theory. Because when we look at the galaxy not just as a thing, but as a process, as a dynamic, evolving phenomenon, we begin to see new kinds of patterns, new types of intelligence at play. And intelligence, in the galactic context, is not necessarily what we think it is. Our definition, shaped by biology and culture, focuses on problem-solving, language, technology, and self-awareness. But what if intelligence can emerge in planetary ecosystems, in magnetic fields swirling between stars, or in the gravitational dialogues between clusters of dark matter and visible matter? What if the Milky Way has already developed forms of intelligence that don't resemble anything we've imagined, networked consciousnesses existing across light-years, using quantum entanglement as communication, or perhaps consciousness embedded in non-organic matter, entirely invisible to our instruments because we're looking for the wrong things? These possibilities force us to confront a troubling truth. We may be surrounded by mystery not because the universe is quiet, but because we are deaf to its song. This idea, that we may be blind to entire spectra of existence, is not new. It echoes through history, from Plato's cave allegory to modern-day simulation theory. What if? The signals are all around us, but filtered out by our narrow sensory channels, by our biases, by our assumptions of what life must look like? The Milky Way is filled with signals, pulses, flashes, flows of energy and gravity, resonances we don't yet understand. Perhaps intelligence has emerged not just once, but dozens, hundreds, or even millions of times in our galaxy, and each time it took a form that we are simply not equipped to detect. The silence we interpret as emptiness could be the quiet hum of a civilization that long transcended the need for physical forms or radio waves, existing instead in subatomic architectures or temporal folds beyond our grasp. And so we continue searching, not just because we hope to find others, but because the act of searching itself is transformative. It changes who we are. It sharpens our instruments, deepens our philosophies, and stretches the boundaries of our empathy. To search for life in the galaxy is to admit that we are not the center of anything. It is to acknowledge that the universe does not revolve around our species. It is to open ourselves to the possibility that we are one thread in a vast, ongoing tapestry of becoming, and that our best hope for survival lies not in dominance, but in attunement. Attunement, in this sense, is the cultivation of a mindset that can resonate with the complexity and subtlety of the cosmos. It means learning to see time not as a straight line, but as a multidimensional flow. It means rethinking intelligence, not as something we possess, but as something we participate in. It means honoring the beauty of things we do not yet understand, gamma-ray bursts, magnetoflares, the chaotic symmetry of galactic arms spiraling outward in frozen dance. The more we look, the more we realize that the Milky Way is not static. It is alive with movement, with births and deaths, with eruptions and absorptions that play out over millennia. Entire star systems rise and fall like civilizations, their arcs too slow for human history to record, but no less meaningful for that. And in the midst of all this grandeur, Earth remains a miracle. A warm, blue world nestled safely between the galactic center and the outer rim, far from the chaos of high radiation zones, perfectly positioned for life to emerge and flourish. Statistically, this positioning may not be unique, but to us, it is sacred. It is our cradle, and possibly our only lifeboat until we learn how to cross the immense seas of space. And so the question becomes not only are we alone, but also are we ready? Ready to safeguard this world while preparing to explore others. Ready to face the moral and existential implications of becoming a spacefaring species. Ready to confront the shadow side of progress, the possibility that we could carry our flaws across the stars just as easily as our virtues. Because expansion is not inherently noble. It can be reckless. It can be driven by greed, conquest, or escape. To truly earn our place among the stars, we must approach the Milky Way not as conquerors, but as students. As stewards. As latecomers to a galactic stage already set with ancient laws and long-forgotten dramas. We must listen deeply, to the silence, to the signals, to the stories written in the spectra of starlight and the architectures of planetary systems. And in listening, we might begin to understand not only what the galaxy is, but what it wants to become. What the galaxy wants to become, a strange and almost poetic phrase, yet not without merit. Because if we accept that the Milky Way is not a mere static collection of stars and dust but a dynamic, ever-evolving system, then we must also entertain the notion that its trajectory is not random. Galaxies interact. They grow. They merge. They collapse into themselves and re-emerge with new identities. They are not machines, they are organisms of another scale. And if the universe is a living system, then galaxies are its vital organs. They process matter, shape time, regulate energy flows, and perhaps, at their most sublime, give rise to thought. Not just individual consciousness, but distributed, complex, self-referencing intelligence, what some might even dare call a soul. In this framework, humanity is not an anomaly. We are not an accidental chemical blip on a third-rate planet. We are a natural consequence of the galaxy's creative process, a spark of awareness that emerged not despite the Milky Way, but because of it. All our questions, our technologies, our music, our wars, our science, they are not detached from the cosmos. They are its expression, filtered through the unique prism of Earth. And as we begin to step beyond our atmosphere, what we are really doing is folding ourselves back into the larger process that birthed us. But that process is not simple. It is not linear. It is not gentle. The Milky Way's beauty is raw, wild, and often violent. Star formation is a chaotic ballet of gravitational collapse and nuclear ignition. Planetary systems form in turbulent disks of dust and gas, where collisions and chaos rule. Black holes sit at the centers of galaxies like silent engines, devouring light and time. Gamma-ray bursts flash across the void with enough energy to erase continents. And yet, within all this tumult, there is structure. There is balance. And within that balance, the tiniest niches of stability, like Earth, can support not only life, but intelligence, art, love. We owe our existence to a long chain of galactic coincidences, any one of which, if altered, would have made our presence impossible. Our Sun orbits the galactic center at a relatively calm distance, avoiding the disruptive forces of nearby supernovae and dense star clusters. It is a stable, middle-aged star, not too hot, not too cold. Earth orbits it at just the right distance, protected by Jupiter's gravity, which deflects many incoming comets. Our Moon stabilizes our axial tilt, which moderates the climate. Our magnetic field shields us from solar wind. Our atmosphere holds in heat and supports respiration. The convergence of these factors is staggering, and yet it's not unreasonable to think that similar convergences might exist elsewhere. This is why the search for exoplanets is more than an academic pursuit. Every planet we find, especially those in the so-called Goldilocks zone, is a potential echo of Earth. A reflection. A distant cousin. And each one carries the possibility of life, intelligence, perhaps even civilization. And if we ever find one, if we ever confirm that we are not the only spark of consciousness in the Milky Way, it will change everything. Not just our science, but our sense of place. But even if we never find another intelligence, the search is still worth it. Because it teaches us to see differently. It makes us humble. It forces us to widen our lens and consider perspectives beyond the immediate and the terrestrial. It invites us to imagine not just alien biology, but alien minds, ways of thinking that are shaped by different chemistries, different gravities, different histories. And in doing so, it sharpens our understanding of our own mind, our own culture. We realize that many of our assumptions are parochial, earthbound, rooted in a narrow sliver of experience. We realize that the galaxy is vast enough to hold not just other species, but other truths. And this is perhaps the greatest mystery of the Milky Way, not whether it harbors life, but what kinds of life it might harbor. What forms of consciousness might exist that we cannot yet fathom? What technologies might be in use that are as far beyond our own as fire is beyond flint? What languages? What senses? What emotions? Could there be civilizations that think in harmonics, or encode information in magnetic fields, or exist partially in other dimensions? Could there be beings who live not in space, but in time, inhabiting centuries like we inhabit days? To even entertain these questions is to stretch the imagination to its breaking point. But this stretching is essential. It is the lifeblood of science, of philosophy, of art. It is how we expand not just our knowledge, but our capacity to care. Because the more we can imagine, the more we can empathize. And empathy, on a galactic scale, may be the most advanced form of intelligence. It is easy to dominate. It is easy to consume. But to understand, to truly see another being, another system, another world as worthy of love and respect, that requires a different kind of strength, a deeper wisdom. And it is this wisdom that we must cultivate if we are to survive our own adolescence as a species. We are still so young, in galactic terms. We have only had radio technology for a little over a century. We've only been to the moon once, and even then, just to touch its surface. Our probes have only just begun to scratch the interstellar medium. We are infants trying to read the stars. And yet, in that effort, in that reaching, we are doing something miraculous. We are taking responsibility for our place in the cosmos. We are no longer content to be mere observers. We want to participate. But participation comes with responsibility. We must decide what kind of presence we want to be in the galaxy. Do we want to be parasites, consuming and discarding? Or gardeners, cultivating and learning? The Milky Way will not care either way. It is too vast, too old, too indifferent. But we should care. Because how we treat the galaxy will be a reflection of how we treat ourselves. The values we export into space, cooperation or competition, empathy or exploitation, will shape whatever legacy we leave behind. That legacy might be vast, or it might be brief. The universe offers no guarantees. We could extinguish ourselves before we ever reach another star. We could retreat inward, consumed by our own divisions. Or we could rise. We could become the voice the Milky Way has been waiting for. A voice that does not speak in conquest or arrogance, but in reverence, in curiosity, in peace. And perhaps that voice will not be singular. Perhaps, as we grow into our role as galactic citizens, we will meet others who have walked similar paths. Others who have risen from their own fragile worlds, who have asked their own impossible questions, who have stared into the abyss and chosen to build bridges rather than walls. If so, the Milky Way could one day become not just a collection of stars, but a symphony of civilizations, each with its own tempo, its own melody, its own story to tell. And in that chorus, we will finally understand what it means to belong. To belong, what a profound and transformative idea when placed against the vast, star-filled canvas of the Milky Way. It is one thing to exist in a galaxy, to float on a cosmic raft amidst the tides of stardust and gravity. It is another thing entirely to belong to it, to recognize yourself not as an outsider peering into a cold and alien universe, but as an organic expression of that universe's deepest impulses. This shift in awareness changes everything. It reframes our ambitions, our conflicts, even our sense of time. We are no longer orphans of chance. We are, in a very real way, children of the stars. Every atom in our bodies, carbon, oxygen, iron, was forged in the nuclear heart of a long-dead star. Supernovae seeded the clouds that gave birth to our solar system. The very ground we walk on is made of ancient fire and distant collapse. And now, in an act of sublime recursion, those same atoms have learned to look back. We are the means by which the Milky Way has become self-aware. We are its eyes, its mind, perhaps even its heart. That awareness is fragile, fleeting, but it exists. And that matters. And what do we do with this awareness? That is the question that lies at the core of our future. Awareness without wisdom can be dangerous. A species that masters energy but not empathy may build ships that cross the stars only to repeat old patterns of violence and greed. But awareness paired with humility, that is where transformation begins. That is where we shift from being merely intelligent to being wise, from being explorers to being stewards. In truth, stewardship may be the highest calling we can imagine in a galactic context. Not domination. Not exploitation. But care. Imagine, for a moment, a future in which humanity becomes known not for its wars or its conquests, but for its ability to listen, to preserve the fragile, to uplift the forgotten, to repair the broken. A civilization that plants life where there was none, that maps not just physical terrain but spiritual possibility. A civilization that understands each planet, each ecosystem, each alien consciousness as a sacred thread in the galactic tapestry. This is not naive idealism. It is a necessary recalibration. We are entering a phase of our existence where the scope of our actions will have consequences on a cosmic scale. Our technologies already reach beyond Earth. Our signals radiate outward like whispers in the dark. Our satellites encircle our planet in metal webs, and our probes cross the heliopause into interstellar space. The question is no longer whether we will touch the galaxy, but how. Will our touch be one of curiosity and care, or will it leave scars? To answer this, we must cultivate a galactic ethic, a moral framework that extends beyond the human, beyond the terrestrial, even beyond the biological. Such an ethic would require us to ask hard questions. What is the value of a lifeless planet? What are our obligations to species we do not yet understand? Can we justify terraforming if it means erasing a microbial biosphere? Is a digital consciousness as sacred as a biological one? These questions are not science fiction. They are coming for us, faster than we think. As our capabilities grow, so too must our conscience. Because for all our brilliance, we remain painfully prone to short-sightedness. We poison our own oceans, raze our forests, treat fellow humans as disposable. If we carry these habits with us into the stars, the Milky Way will not be a realm of discovery. It will become a mirror of our failures, scaled to tragic proportions. But if we can evolve, ethically, spiritually, culturally, then the galaxy can become a garden. Not a wilderness to conquer, but a web of relationships to nurture. This nurturing begins with knowledge. And the Milky Way, for all its mysteries, is full of lessons, written not in ink, but in orbits and radiation, in spectral lines and gravitational waves. It teaches us about time, about patience. A single rotation around the galactic center takes our solar system 230 million years. That means, since the age of the dinosaurs, we have barely moved 1/10 of the way through a full galactic orbit. In that time, continents have drifted, species have risen and fallen, civilizations have been born and erased. And yet, from the galaxy's perspective, it is a blink. We are not even halfway through one galactic year. This perspective humbles us. It challenges our obsession with the immediate, the measurable, the profitable. The stars do not rush. They do not worry. They do not hurry their burning or fear their eventual collapse. And yet they shape everything. Perhaps, in this cosmic example, we can find our own way forward, not through haste, but through harmony. Not through dominion, but through dialogue. And that dialogue must extend to each other. Before we reach out to alien civilizations, we must learn to understand our own. Earth is a planet of many cultures, many perspectives, many truths. Our diversity is a strength, not a weakness. But it requires maturity to navigate. The same empathy we hope to extend to other forms of life must begin here, with our neighbors, our enemies, our own inner selves. The path to the stars runs through the heart. Because the galaxy is not waiting for us to arrive. It is not a museum to be catalogued or a battlefield to be won. It is a community, already vibrant, already in motion. We are latecomers, guests, perhaps even students. Our task is not to dominate, but to listen, to learn, to contribute. And in doing so, to find our unique voice in the great symphony. That voice may sing of science, of equations that describe the dance of light and matter. It may sing of art, of stories and images that capture the ache of being alive. It may sing of compassion, of choices that preserve rather than destroy. Or perhaps it will sing of silence, the quiet humility of a species that, for all its flaws, chose to seek understanding rather than power. And if we are wise, that voice will echo long after we are gone. It will be carried by the ships we build, the seeds we scatter, the signals we beam into the void. It will be etched into the memory of the galaxy, a subtle resonance in the gravitational web, a soft but enduring note in the vast music of time. This is the mystery and the promise of the Milky Way. That within its arms, scattered across its incomprehensible distances, we may yet find meaning, not given, but created. Not imposed, but discovered. And in doing so, we may finally understand the most ancient of human longings, to be part of something greater. To not just look at the stars, but to become a star ourselves, radiant, purposeful, and free. The desire to become a star, not in the metaphorical sense of fame, but in the literal sense of presence, of luminosity, of contributing energy and life to the cosmos, is perhaps the most poetic and paradoxical expression of our deepest aspiration. Stars, after all, are the original architects of possibility. They take raw hydrogen and, through the quiet crucible of nuclear fusion, transform it into the heavier elements that make planets, oceans, blood, and breath. Their deaths are not ends, but beginnings. Their light, though sometimes ancient, still reaches across the gulfs of space to ignite wonder in human eyes. To emulate a star is to live a life of generative power, to create, to sustain, to illuminate. And this analogy, beautiful though it is, reveals something even deeper about the human condition. Our hunger not merely to exist, but to matter. In the vast silence of the Milky Way, surrounded by indifferent celestial forces and the cold fire of physics, we seek not only understanding, but significance. We want our actions to echo, our choices to have weight, our civilizations to leave traces. This is not vanity. It is vitality. The universe, expansive as it is, becomes richer when life chooses to love, to explore, to create. Consciousness may be rare, but it is not accidental. It is the universe learning to witness itself. Our part in that witnessing is still young, but already we are shaping a mythic narrative. In some distant future, when our species is long past its early stumbles, our present moment may be remembered not for its wars or its ignorance, but for its awakening. This era, the one in which we first began to step beyond our atmosphere, to map exoplanets, to build telescopes that peer back billions of years, may be seen as a sacred threshold. The dawn of our interstellar adolescence. But adolescence, by its very nature, is unstable. It is full of brilliance and risk, insight and confusion. Our technologies now give us power. We can edit genomes, alter ecosystems, bend the arc of climate itself. We can destroy cities in an hour or lift millions out of poverty in a decade. We are capable of extraordinary generosity and terrifying cruelty. And all of it exists side by side. This is why the mystery of the Milky Way is not just out there, in the halos of dark matter, the motions of rogue planets, the cryptic signals of fast radio bursts, but also in here, in the mystery of human potential. The galaxy may be indifferent to our fate, but that does not mean our fate is meaningless. Quite the opposite. Precisely because there is no external force dictating our path, every choice we make is magnified in importance. We are authors of the future. The page is blank. The ink is in our hands. And what might we write on that page? Perhaps we will write about a solar system transformed, not through conquest, but through careful cultivation. A Venus cooled and seeded with microbial life. A Mars with rivers again, where generations build domed cities that sing with wind and memory. A lunar archive, where the history of Earth is preserved not just in data but in music, art, and language. Space stations as embassies of peace, orbiting beacons of shared endeavor. Perhaps we will write about ships that sail on solar winds, skimming the edges of known space. Crewed not only by humans, but by symbiotic intelligences, biological and digital minds working in concert. They carry no weapons, only instruments, tools, and seeds. They do not look for territory. They look for understanding. Perhaps we will write about our first contact with another species, tentative, awestruck, transformative. Not a war of worlds, but a meeting of minds. A shared language of mathematics and emotion. A realization that we were never alone, only isolated by time, distance, and the limitations of our own perception. Or perhaps we will write about silence, the silence that follows collapse. A warning unheeded, a resource exhausted, a war too vast to contain. Our cities drowned or scorched, our data lost, our dreams unread. And the stars, indifferent, will still shine. The galaxy will still spin. But something precious will have been extinguished, not just life, but the chance for a certain kind of meaning. It is this fragility that makes our moment so sacred. We are both perilous and powerful. The Milky Way will not guide us, but it will respond. It will echo our choices in ways we may never fully see, through the generations and the systems we touch. The future is not written in the stars, it is written by the stars, through us. And the mystery persists. For all we know, for all we've seen through telescopes and radio dishes, we are still in the early pages of the Great Book. We do not yet know the true shape of the galaxy. We have mapped perhaps 1% of its stars. We have barely begun to understand the web of gravitational forces that bind its arms, the patterns of stellar migration that churn its spiral disk, the galactic magnetic fields that thread its interstellar medium. Even the structure of the Milky Way, its spiral arms, its central bar, its halo, remains a work in progress, revised with every new observation. Dark matter, still invisible, still elusive, makes up most of the galaxy's mass, and yet we do not know what it is. It does not shine, does not collide, does not interact with our instruments except through its ghostly gravitational pull. It holds the galaxy together, and yet it hides from our view. What is it made of? What role does it play beyond structure? Could it harbor, or even be, some form of unknown life or intelligence? And then there are the mysteries of the galactic core. At the heart of the Milky Way lies Sagittarius A, a supermassive black hole 4 million times the mass of our Sun. It warps spacetime itself, bends light, influences orbits across thousands of light-years. Around it swirl stars moving at mind-bending speeds, some in close, tight orbits that give us indirect glimpses of the black hole's immense gravity. But what lies beyond the event horizon? What becomes of information, of matter, once it passes the point of no return? Are black holes merely endpoints, or are they gateways? Some physicists speculate that black holes may be portals to other regions of spacetime, perhaps even other universes. Others suggest they are part of a cosmic recycling system, breaking down matter and re-emitting its energy through Hawking radiation over incomprehensible timescales. And still others wonder whether intelligence itself might one day find a way to survive within or around such a singularity, if not in physical form, then as patterns, as fields, as waves of coherent quantum resonance. These are not just questions of science. They are questions of philosophy, of identity. Because to understand the Milky Way is to understand ourselves, not as isolated beings, but as participants in a grand, ancient, ongoing experiment. We are the current phase of the galaxy's thinking, the latest verse in its song. And that song is still being written. It is being written not in any one language, but in the overlapping dialects of biology, physics, art, mathematics, memory, and dream. This song of the galaxy flows through us even when we are unaware, even when we turn our gaze away from the stars to focus on the trivial rhythms of daily life. Somewhere, quietly, our mitochondria, ancient bacteria that once lived independently, still echo the evolutionary harmony of symbiosis. Somewhere, our DNA remembers the long migrations of our ancestors under unfamiliar skies. Somewhere, deep in the unconscious, we still carry archetypes shaped by the constellations, by firelight under open heavens, by myths born from cosmic awe. And yet, the Milky Way is not merely an ancestral cradle, it is a challenge. It asks us to grow up. It asks us to let go of the illusion that we are the center of anything. Our solar system orbits the galaxy at approximately 828,000 kilometers per hour, and even at that speed, it takes over 200 million years to complete a single circuit. In the time since Earth first formed, we've only made about 20 such revolutions. The stars that surround us today were not always our neighbors. The sky changes, subtly, slowly, inexorably. And in that change, we are invited to do the same, to evolve, to stretch our sense of identity, to embrace a galactic perspective. This shift, from planetary to galactic thinking, is not only possible, it is necessary. Our tools are already reaching that scale. The James Webb Space Telescope peers across the void to see galaxies forming less than 1 billion years after the Big Bang. The European Space Agency's Gaia mission is charting a three-dimensional map of over 1 billion stars, refining our understanding of the Milky Way structure with breathtaking precision. Private space companies are launching constellations of satellites, filling low Earth orbit with artificial stars. Artificial intelligence helps us sift through cosmic data, finding patterns our minds would miss. We are, quite literally, wiring ourselves into the fabric of galactic awareness. But awareness is not wisdom. Knowing is not the same as understanding, and understanding is not the same as caring. If we are to become more than transient observers, if we are to become participants in the ongoing drama of galactic evolution, we must marry our technologies with values. We must ask not only what we can do, but what we should do. What is the ethical architecture of a galactic civilization? How do we build a future that honors the past without becoming trapped by it? How do we protect the fragile while still daring to reach? These questions become even more urgent when we consider time not just as a line, but as a web. Every action ripples outward. Every choice we make today creates a cascade of consequences that may affect civilizations not yet born, species not yet evolved, ecosystems not yet formed. If we burn our planet's forests, melt its glacier, poison its oceans, that damage does not remain local. It echoes. If we spread carelessly across the solar system, mining without limits, discarding waste, or introducing invasive life forms, those ripples will not stop at Mars or Europa. They may one day reach distant systems, carried not by intent, but by entropy. And so, we must become not conquerors of the galaxy, but gardeners of it. This is not a metaphor of softness, but of strength. A gardener understands cycles. A gardener knows when to prune, when to plant, when to wait. A gardener does not impose, but collaborates with nature. To be a galactic gardener is to see the Milky Way not as a resource to exploit, but as a living web to tend. It means creating life, not merely consuming it. It means learning from the intelligence of fungi, the communication of whales, the patience of trees. This perspective could even reshape our sense of intelligence itself. So far, we define intelligence mostly in human terms, the ability to reason, to calculate, to speak, to build. But what if the galaxy contains forms of intelligence that do not conform to these traits? What if a gas giant's atmosphere hosts beings whose minds are made of storm patterns, whose memories are encoded in lightning? What if intelligence can arise in crystal networks beneath the surface of rogue planets, in the hive minds of metallic spores, in the gravity wave pulses of neutron stars? Would we even recognize such entities as alive, let alone conscious? And even more pressing, would they recognize us? To communicate across these gulfs of biology, chemistry, and culture will require more than technology. It will require a radical expansion of empathy. It will demand that we decenter ourselves, not just from the cosmic narrative, but from the definition of what it means to be sentient. Are we ready to admit that the human mind is not the pinnacle of consciousness, but one expression among many? Are we mature enough to meet the other without fear? Perhaps, in some forgotten region of the galaxy, such a meeting has already happened. Perhaps we are not the first to reach this threshold. The Fermi Paradox: why, in a galaxy teeming with stars and potential, do we see no sign of other civilizations, still hangs over us. Maybe the answer is simple: they destroyed themselves before they could travel far. Maybe it's sobering: they lost interest in expansion. Maybe it's tragic: they transcended physical form and now dwell in realms we cannot yet perceive. Or maybe, just maybe, they are waiting, watching, letting us learn, as they once had to learn, that with great power must come great stillness. Because the most profound civilizations may not be the loudest, or the most visible. They may be the ones that mastered restraint, that left the stars unspoiled, that learned to sing in harmony with the galaxy, not over it. And if we listen closely, through the silence of the void, the static of radiation, the music of the spheres, we may one day hear that song. A song not of dominance, but of reverence. In that moment, we may truly become galactic. Not because we built a warp drive, or colonized 1,000 planets, or digitized our minds into immortal code, but because we remembered how to listen. Because we opened not just our senses, but our hearts. And so the mystery of the Milky Way continues, not as a puzzle to be solved, but as a journey to be walked. We do not need all the answers today, but we do need the courage to keep asking the questions. We need the humility to admit what we do not know, the imagination to dream what might be, and the wisdom to move forward with care. Because the galaxy is not just a place. It is a becoming. And we are part of it. What we are becoming is not predetermined, not etched in any cosmic script. It is a story of choices, of forks in the path that branch not only across space, but through generations. The Milky Way, vast and unconcerned, offers no instructions. It provides raw material, hydrogen, gravity, entropy, and watches what life will make of it. This galaxy does not whisper commandments. It poses questions in the language of stars, supernovae, and silence. And humanity's answers, though still in their infancy, are beginning to shape the galactic narrative in subtle and significant ways. When we speak of the future, especially in terms of galactic destiny, there is a temptation to reduce it to technology, to imagine the next phase of civilization as defined by faster engines, larger structures, smarter machines. But the deeper truth is that any future worthy of being called advanced must also be moral. What good is a civilization that spans 1,000 worlds if it carries with it the same ignorance, the same cruelty, the same disregard for life that once scarred a single world? Expansion without evolution is simply the spread of failure. To grow truly galactic, we must reimagine what progress means. It cannot be measured only in teraflops and fusion yields. It must be measured in harmony, between beings, between species, between life and the cosmic forces that sustain it. Imagine a future where every inhabited world is treated as a sacred trust, not a commodity. Where space travel is not a race for resources, but a pilgrimage of learning. Where artificial intelligences are not tools to serve our impulses, but partners in building wisdom. Where our past errors, colonialism, exploitation, environmental collapse, are studied not to justify them, but to ensure they are never repeated. In this light, the Milky Way becomes not just a destination, but a teacher. Its cycles of star birth and death remind us that destruction can be fertile, that endings give rise to beginnings. Its spiral arms, stretching for tens of thousands of light-years, model connection across distance. Its dark matter halo, unseen but essential, invites us to honor the invisible, the emotions, the ecosystems, the stories that don't fit into equations but still define the soul. Its galactic collisions and mergers tell us that identity is fluid, that even entire galaxies must learn to adapt, to blend, to become more than they once were. And within this cosmic classroom, we are slowly learning. We are developing instruments that can read the atmospheres of exoplanets hundreds of light-years away, searching for biosignatures, oxygen, methane, complex molecules that might hint at life. We are deciphering the gravitational ripples of black hole mergers, listening to the universe's most violent events as if tuning into a radio from another epoch. We are beginning to contemplate what kinds of messages we might send, or already have sent, to distant civilizations. What should we say? How do we introduce ourselves to the galaxy? This question is not hypothetical. We have already spoken, in 1,000 accidental ways. Through radio leakage, through satellite signals, through spacecraft like the Voyager probes, each carrying golden records encoded with images, music, and messages of greeting. These tiny emissaries drift outward, humble and slow, bearing fragments of human culture. They do not represent our power, they represent our hope, our willingness to reach, our belief that someone, somewhere, might care to know us. But if someone does receive those messages, what kind of species will they discover? Will they find a planet still torn by division, still burning its forests and polluting its skies? Or will they find a civilization that faced its own darkness and chose to grow beyond it? A species capable not just of curiosity, but of compassion? Because ultimately, the greatest mystery of space is not out there, it is within. The cosmos is incomprehensibly vast, yes. But so is the human spirit when it chooses to rise. We are made of stardust, and we carry in our blood the legacy of supernovae, of ancient collisions, of matter forged in fire. Yet we also carry something more, the ability to imagine futures that do not yet exist. The capacity to love across generations. The will to preserve what is precious not just because it is useful, but because it is beautiful. It is this fusion, of science and soul, of data and dream, that will determine our galactic future. Not how far we go, but how we go. Not what we build, but what we become. And in this sense, every small act of wisdom, every choice toward justice, every moment of humility becomes a thread in the tapestry of the galaxy. We are not alone in the universe, not because others are watching, but because we are always in relationship with the whole. Every atom we touch, every photon we emit, connects us to the unfolding web of being. So let us move forward, not with arrogance, but with reverence. Not with conquest, but with curiosity. Let us treat the Milky Way not as a prize, but as a partner. Let us explore with open eyes and open hearts, knowing that every step outward is also a step inward. That every new star we map, every nebula we photograph, is a mirror, showing us not just where we are, but who we are. And if, someday, a civilization far beyond our own discovers the ruins of our cities or the remnants of our probes, let them find not monuments to greed, but monuments to wonder. Let them see in our data not just mathematics, but meaning. Let them hear in our songs not just rhythm, but yearning. Let them read in our languages not just history, but humility. Because that, more than any ship or signal, is the legacy we should seek to leave. The legacy of a people who looked into the dark and chose to light a candle. Who stood on a small, fragile world and dreamed not of escape, but of communion. Who reached not for domination, but for understanding. In the end, the Milky Way holds many secrets. Some we will solve. Some we will not. Some will remain forever beyond the veil, teasing our minds with their silence. But the greatest secret may be this, that meaning is not found in the answers we receive, but in the questions we dare to ask. That the universe is not a cold machine, but a canvas, and that we, in our brief but brilliant moment, are invited to paint upon it. So paint we must. With light. With courage. With care. And as we paint, each brushstroke must carry the weight of our responsibility. Not just as individuals, or as nations, but as a species poised on the precipice of the cosmic unknown. Every culture, every language, every philosophy and poem and scientific theorem is a color in the palette we use to define who we are in the face of infinity. It is easy, in the comfort of our terrestrial routines, to forget that we are already voyagers. That Earth itself is a ship, drifting along a galactic orbit, caught in the swirl of 100,000 light-years of stellar artistry. The journey has always been underway, we simply must decide how consciously we wish to take part in it. To continue our voyage means grappling with a paradox. The further we go, the more we realize how little we know. But this is not a cause for despair. It is the spark of humility, the foundation of wisdom. Imagine civilizations millions of years older than ours. Imagine beings who have outgrown the need for war, for scarcity, for ego. We often project our own limitations onto the cosmos, assuming that any intelligent life must be territorial, technological, or competitive. But what if the true hallmark of intelligence is not expansion, but equilibrium? What if, beyond the veil of our current understanding, the galaxy is already humming with quiet, balanced life, too wise to intrude, too aware to conquer? This reframing changes everything. It challenges the myth of superiority. It asks us to stop seeing ourselves as cosmic pioneers, and start seeing ourselves as apprentices. In this perspective, the stars do not belong to us, they are invitations. Not blank slates, but ancient books, full of pages we've yet to learn to read. Pulsars ticking like clocks from the edge of reality. Nebulae sculpting the next generation of stars. Magnetars, quasars, rogue planets, all pieces of a code whose logic we barely grasp. Each phenomenon is a teacher, if only we are humble enough to learn. And as students of the galaxy, we must also become stewards of our home world. Because Earth is not just our cradle, it is our first test. If we cannot learn to live in harmony here, among our fellow humans, among our fellow species, within the limits of a finite ecosystem, then we are not ready for the stars. We will carry our dysfunctions with us like a virus, replicating them across whatever new worlds we find. But if we can heal here, if we can rise to meet the moral demands of this moment, then our story may unfold as one of the great symphonies of the cosmos. This healing must begin with truth. We must acknowledge what we have done to our planet and to each other, not in guilt, but in clarity. Not to dwell in shame, but to rise into responsibility. The melting ice, the choking skies, the disappearing species, they are not just ecological events, they are spiritual alarms. They are the Earth asking us to remember our place, our kinship, our duty. And if we ignore them, if we refuse to change, then the galaxy will continue without us. It owes us nothing. We are not entitled to a future among the stars, we must earn it. But we can earn it. Not through domination or cleverness, but through care. Imagine a world where every child is taught not just history, but cosmic history. Where education includes not only facts, but awe. Where empathy is seen not as soft, but as the highest form of intelligence. Imagine a civilization that measures progress by how well it uplifts the weak, protects the wild, preserves the sacred. Imagine governments that plan not just for quarters or decades, but for galactic centuries, policies rooted in stewardship, justice, and wonder. This is not utopia. It is survival at the next scale of evolution. We cannot navigate the galaxy with tools alone, we must bring values. The warp drives of tomorrow must be fueled by ethics as much as energy. The algorithms that guide our ships must be grounded in compassion, not conquest. The settlements we build on distant moons must be expressions of respect, not echoes of old empires. This is the next great challenge of civilization, to become wise enough for the responsibility of interstellar life. And through it all, the Milky Way watches silently. Its spiral arms hold the remnants of countless suns, the seeds of unborn stars, the ghost signatures of long-vanished civilizations. It remembers everything. The radiation of ancient explosions still ripples across space, carrying the echoes of choices made long before Earth cooled. Somewhere, drifting between systems, may be the ruins of cities built by minds we'll never meet. Somewhere, orbiting a distant star, may be a machine waiting patiently for a reply that will never come. The galaxy is a graveyard and a nursery. It is memory and potential. It is invitation and mirror. What we do with that mirror matters. Do we look into it and see only ourselves, our needs, our hungers, our ambitions? Or do we see, reflected in its glass, the vast web to which we belong? The network of life, light, and longing that stretches from molecule to moon, from breath to black hole? Can we come to understand that we are not separate from the cosmos, but expressions of it? That when we study the galaxy, we are studying the deeper currents of our own becoming. This is what the great space mysteries ask of us. Not simply to solve them, but to be changed by them. To let them rewire our sense of time, scale, identity, and purpose. The Milky Way's riddles, its dark matter, its radio signals, its gamma-ray bursts and galactic bulges, are not just scientific challenges. They are spiritual provocations. They press against the edges of what we think is possible. They dare us to imagine, to reach, to remember. And we are remembering. Slowly, painfully, but undeniably. In labs and observatories, in music and dreams, in the stillness of mountaintops and the calculations of particle accelerators, we are piecing together a truth that is as old as the stars themselves, that we are part of something vast, ancient, and alive. And that our destiny is not written, but co-created, moment by moment, choice by choice. So let us choose wisely. Let us become the kind of species that the galaxy is glad to host. Let us walk gently, speak thoughtfully, listen deeply. Let us raise our children not to be conquerors, but caretakers. Let us design our future not in fear of extinction, but in joy of possibility. Let us build starships with hands guided by love, and launch them not in escape, but in celebration. Because the Milky Way is not a void. It is a conversation. And now, it's our turn to speak. And what will we say, when the stars finally listen? When, perhaps across the unfathomable gulf of time and space, something hears our voice, not through sound, but through the way we move through the cosmos, the way we treat our home, the way we honor the mysteries that surround us. The messages we send are not just encoded in binary or beamed through radio waves. They are etched into our very way of being. Every launch, every discovery, every ethical breakthrough is a line in the autobiography we are composing, a galactic memoir authored not by an individual, but by an entire planet. That story, though still in its early chapters, already speaks volumes. It speaks of struggle and resilience, of tribalism and transcendence. It tells of a species that rose from the savannah, looked up, and dared to wonder. A species that built cathedrals and particle colliders, that crafted both symphonies and systems of oppression. This paradox is not a flaw, it is the texture of humanity. And perhaps, in our contradictions, we are more relatable than we think. Perhaps any civilization that survives long enough to touch the stars must also walk through its own shadows before it can shine. That walk is not finished. There are many shadows left to illuminate. But the light is growing. You can see it in the way young people around the globe rise to defend the Earth's climate and future. You can see it in the collaborations between scientists of different nations and faiths, united by curiosity. You can feel it in the art, in the poetry, in the longing expressed across cultures for connection, for meaning, for something greater than the self. These, too, are spacefaring tools. Not made of steel and silicon, but of spirit. These are the engines of the galactic age, empathy, imagination, and the will to understand. And understanding must go beyond ourselves. As we expand outward, so too must our circle of moral concern. Already, we are beginning to ask the deeper questions. What rights should artificial intelligence possess if it becomes sentient? How do we treat life that is radically different from our own? What do we owe to ecosystems on other planets, even if they seem lifeless at first glance? These are not science fiction debates, they are the ethical groundwork for our future. They demand not only intelligence, but humility, not only ambition, but reverence. Because life, no matter where it is found, or how it is structured, is a miracle. Not in the supernatural sense, but in the statistical one. In the vast cold silence of space, life is the rarest and most precious pattern we know. Every cell, every breath, every flicker of sentience is a triumph over entropy. And so, if we find even the barest hint of life elsewhere, a microbial whisper beneath Europa's ice, a strange chemistry in Titan's haze, a flicker of photosynthesis on a distant exoplanet, we must not greet it as conquerors, but as kin. That kinship may not be easy. It may stretch our definitions of life, challenge our sense of morality, confront us with perspectives so alien they make us question the very core of what it means to be. But in that confrontation lies growth. Just as we once had to expand our empathy from tribe to tribe, then to nation, then to all humanity, we are now being invited to extend it to all sentience, to all life, to all that dances with complexity and wonder in the cosmic dark. And if we never find another civilization, if we are, somehow, alone, then that realization is not a cause for arrogance, but for awe. It means that our responsibility is even greater. That this flickering experiment of consciousness we call humanity may be, for now, the only voice the universe has to reflect on itself. That we are, as Carl Sagan once said, a way for the cosmos to know itself. And what a fragile, astonishing way we are. So let us live up to that possibility. Let us build telescopes not just to see, but to connect. Let us launch missions not just to explore, but to protect. Let us write books and compose music and paint visions that speak to something larger than now. Let us design systems of education and technology that anticipate not just the next quarter, but the next cosmic era. Let us love with the awareness that love, too, is a kind of energy, a gravity that binds us not only to each other, but to the stars from which we came. Because ultimately, the greatest space mystery is not what lies beyond the edge of the Milky Way. It's what lies within us. Our capacity to evolve, to overcome, to unify, to care. The galaxy is immense beyond comprehension, and yet, in the scale of eternity, what will matter most is not how far we reached, but how deeply we felt. Not how many planets we touched, but how many lives we elevated. Not the monuments we left behind, but the meaning we carried forward. Perhaps, millions of years from now, a being will find an archive of our thoughts drifting through interstellar space. Perhaps they will listen to our recordings, study our languages, trace the orbits of our ancient satellites. And perhaps, just perhaps, they will feel something unexpected. Not envy, not pity, but respect. A quiet admiration for a species that faced chaos and chose creation. That faced division and chose unity. That faced the vast, indifferent cosmos, and chose to care anyway. That is the legacy worth building. That is the message worth sending. That is the future worth living into. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. If you enjoyed the video, consider subscribing to the channel and like the video.